So here we have this question that says, use the elimination method. That means if you don't use the elimination method, you're not answering the question. So we want to use the elimination method to solve for the values of x and y in the system of equations. So here we have two equations. The first thing we're going to want to do is to label our equations. So I'm going to call this equation 1 and equation 2. We want to look for the easier variable to eliminate, and to identify that, the variables we have are x and y, x and y. So if I look at the variable y in equation 1, notice that it has this 2 in front of it. And if I look at the variable y in equation 2, it also has this 2 in front of it. So straight away, the easier variable to eliminate or get rid of is the variable y. So how are we going to get rid of y? So there's a rule that says if the signs on the coefficients are the same, then we need to subtract. And if the signs on the coefficients are different, then we need to just simply add. So this is what I mean. See that it has this 2 here. The sign on this 2 is positive, but this 2, the sign on it is negative. So the rule says once you have opposite signs, you're going to add, but if the signs were the same on the 2's or on the variables, the coefficients that are the same, then you're going to subtract. So seeing that this is a positive 2 and this is a negative 2, then we're just going to add them, right? So I'm going to go ahead and show you what I would do. I would do this and this to the entire equation 2, and then I'm going to add them. Look at what happens, and I think this is very interesting. So I'm gonna have to distribute this positive sign inside the entire equation 2. Look at what that does. So a positive with this positive 5x is going to give me positive 5x. Then I'm going to distribute this positive with this negative 2y, and a positive with a negative is going to give us a negative equal sign. I'm going to distribute this positive again to this 1 out there. So this is still going to be positive 1. And I'm putting that plus for a particular reason. Then I'm just going to bring back down equation 1 and write 3x plus that 2y is equal to that 7. Good. And from here it is very simple. I just draw a line and then just work it out. And the reason why I put back this plus is because a positive with a positive give you a positive. So look what happens now. I'm just going to work vertically. Alright? So I have 3 x's and I add 5 more x's to it. That should give me 8 x's. And then I have 2 y's and I take away 2 y's from it. Well, I'm going to end up with 0. So this is why it's cancelled, it eliminates, and that's the whole purpose behind the elimination method. Still not done yet. There's a big equal sign. So now it says 7 plus 1. Everybody knows that's 8. So now I need to solve for the value of x. So if 8x is equal to 8, simply I could just divide both sides by 8. So I get x on its own. So this cancels, leaving me just x by itself. That's what we're after. And 8 divided by 8 gives us 1. So the value of x is 1. Easy. So what I like to say next is, since x is equal to 1, substitute x equal 1 into any equation. And I'm going to select equation 1 into equation 1. So remember, equation 1 was that 3x plus 2y is equal to 7. And remember, we said that since x is equal to 1 now, I'm going to substitute or change over or take out x and put in 1. So I'm going to take out this x and I'm going to put in 1 in its place. And when we're substituting, we're going to use brackets to show that we're changing. Just like in football, they put up a card to show that, you're substituting a player for another player. And I'm going to keep back everything that's before the x and after the x. Now remember, when you see it like this, it means to do what? To multiply. So 3 times 1 is 3. And then I'm going to have plus 2y is equal to 7. Now our aim is to solve for the value of y. So I'm going to take this 3. And look, on this side, the left side, it's positive. So when I carry it across the equal sign, it's going to become its opposite, negative. So I'm going to have 2y is equal to 7 minus 3. And 7 minus 3, we work that out to be 4. So 2y is equal to 4. Y is still not by itself. We need to get rid of this 2. So I'm going to divide both sides by 2 to get y on its own. So this will cancel, leaving us with just y. And 4 divided by 2 is 2. So the value of y is 2. So to clean it all up, we come to the side and we would say, therefore, x is equal to 1 and y is equal to 2. And you can leave it like that. To make sure that you're correct, you want to check your answer by substituting the values inside any other equations to make sure that it actually works. So I'm going to start with this one. Alright, we said that x was 1. And then we said that y was 2. Alright, so let's look at this. 3 times 1 is 3. And I'm going to add to that 2 times 2. This 2 times 2 is 4. 3 plus 4, is it 7? If that is true, then you know your answer right. Let's check it with this one. We said that x was 1. Alright? And then we said that y was 2. So look now. 5 times 1, that's supposed to give me 5. And I'm going to subtract from that now 2 times 2, which is 4. So 5 take away 4. 5 take away 4. We know that's 1. And you look, it's 1. So that proves to me that my answer, x is equal to 1 and y is equal to 2, that this is actually correct.